Distance learning curricula in cloud computing, compute services, content prepared by Frane Urem. Good afternoon and welcome to the cloud computing course. This course was developed as a result of the Erasmus Plus project Code-In. All you need for learning is internet access and a computer. The course contains a total of 10 topics, and in this topic, we will say something more about the cloud compute services. There are a number of different computing configurations that can be used in cloud computing. What you use depends on your real needs. The traditional approach is where you want to have your own physical, bare metal or dedicated virtual hosts that you do not want to share with other public end users. You can also use virtual servers installed on shared infrastructure. In the context of scalability and using only what you need from a compute instance, you can use configurations with containers and functions. In bare metal servers, you get a full machine, an entire server completely dedicated to you. A dedicated host means that you get a fully dedicated bare metal machine. However, on top of that, you could run virtual machines. So, what is the difference between dedicated hosts and virtual machines? Virtual machines are shared and multi-tenant, meaning the host can be running them from multiple users. They have strong security isolation, so you do not have to worry about that. However, some users want a dedicated host to run their own VMs and do not have VMs from any other customer running there. That option is also provided by using a dedicated host. Bare metal configuration is used when you want your own high-performance hardware available in the cloud, but use software that cannot run on virtual machines and has specific licensing. It is also possible that on such hardware, you want to have a particular hypervisor on which you will install virtual machines. However, you use a shared cloud infrastructure in the context of the data center that houses that hardware. Virtual machines still mean the traditional approach of managing to compute instances. Even though you do not have problems with specific hardware and malfunctions, you still have to worry about the entire configuration, which means operating system patch management, security configuration, monitoring application configuration, and scaling to handle variable traffic. When we say an instance, what we mean is a compute host, and it has several dependencies. The compute host's first dependency is on a virtual cloud network. The compute instances have another set of dependencies: the boot volume, the boot disk, and the block volumes. What do these mean? Well, each of these compute hosts you are spinning up has an operating system, and the image used to launch an instance determines its operating system and other software. That comes from this network storage disk called a boot disk, so it does not stay on the compute host. It is living on the network somewhere. Vertical scaling means you are scaling up or scaling down instant shapes. Now, what can you scale? Well, you can scale the CPU, memory, and some of the other characteristics accordingly. The important thing to remember here is when you scale up or down. When we instantiate a new shape, it goes to another host, so some downtime is required. So keep that in mind when you do vertical scaling. There is another scaling called auto-scaling, also referred to as horizontal scaling. Now, as you can see in the picture, this basically means that you add more VMs of the same shape or take away more VMs of the same shape. This enables the large-scale deployment of VMs. There is scale-in, where you go from one VM to many VMs, or scale-out, where you go back from many to one VM. Why is this so popular and powerful? It is so powerful because it gives you that scaling capability, but it also gives you that high availability. In this case, if one virtual machine fails, others can keep working. Early on, organizations ran applications on physical servers. Unfortunately, there was no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. As a solution, virtualization was introduced. It allows you to run multiple virtual machines, VMs, on a single physical server's CPU. As a result, virtualization allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily, reduces hardware costs, and much more. Containers are similar to VMs, but have relaxed isolation properties to share the operating system, OS, among the applications. Therefore, containers are considered lightweight. Similar to a VM, a container has its file system, the share of CPU, memory, process space, and more. However, decoupled from the underlying infrastructure, they are portable across clouds and OS distributions. Containers are an excellent way to bundle and run your applications. However, in a production environment, you need to manage the containers that run the applications and ensure that there is no downtime. For example, another container needs to start if a container goes down. Wouldn't it be easier if a system handled this behavior? That is how Kubernetes comes to the rescue. Kubernetes provides you with a framework to run distributed systems resiliently. It takes care of scaling and failover for your application, provides deployment patterns, and more. For example, Kubernetes can easily manage a canary deployment for your system. Kubernetes represents a journey towards functions where you write your code in a particular runtime, and then you do not worry about servers. You do not worry about any of the infrastructures. You just provide the code, and the cloud provider is responsible for executing that code. And one of the most significant advantages here is it truly leads you to a consumption-based pricing model where you're only billed for the time your function is running. To complete this unit, study and review the following online resources. Thank you for attention.